All right, everyone. Thank you so much for coming to our last workshop. So today we have George Wu. He got his MBA from the University of Michigan and an EECS degree from Berkeley. So he started off as an engineer and currently works as a product manager at Sharp. So pretty varied background. So today he's going to talk about careers in AI. So you can go ahead.
All right, sure. Sounds good. Thanks for having me. I'm always glad to give back. I know when I was a student, I had a lot of confusion about what to do, etc. So if there's any questions, any part of the presentation can stop me whatsoever. I'll do my best to answer all your questions. So to kind of elaborate a bit more background, so I was an EECS major, so I'm assuming all of you guys were CS or EECS. So I know what you guys are going through. People are having fun. You guys are doing your work, so I understand. So I've transitioned actually to product management, as the president said, where I'm now working more towards working with engineers and designers, figure out how to launch new products into market. So I was telling some of the students here, I haven't touched a line of code for 2 years, and I went to hackathon this past weekend, and I couldn't get my code to compile. So it was one of those. Make sure to keep at it. So I've kind of broken it into 2 different sections. My presentation is pretty generic. I didn't create a fancy slide, so I apologize for that. One is basically background information on some of the core skills you need to use to get during your time here. What class that is, it's up to you guys to decide. I'm sure you guys know better than I do. I don't go to UCI. And then second is more of the individual career profile, a generic profile of each of the positions within a typical AI company. So here's background information, very generic. It's basically, 3 things: math, programming skills, obviously, right? And everything else an extra. So the first thing is make sure you understand your math really well, because a lot of AI is based on math. That can be calculus, statistics, those two. I would have more statistics than calculus, but even then, you need to know both of them to some level of degree of fluency. And of course, a lot of programming languages, right? Well, I'm sure once you learn a few of them, each one becomes easier to learn. It's basically similar syntax, similar mindset, it's just the way you communicate is different. So those are the same. Now, those are 2 areas you get those down quickly, because almost everything you do requires programming nowadays, right? And some level of math, especially with AI field. So after you get those, then you can start branching into the more advanced topics, like natural language processing, how they work, machine learning, etc. So that's how I will actually advise as well. Get those 2 basic foundation down. You need both for sure. And then only then, when start delving into more of the specifics of the AI topics. Now, so here's a typical, not any company, how a typical AI team is structured, a data sciences team, data team is structured. So you have usually, say the smallest division is basically 1 data scientist to 2 data engineers or machine learning engineers, how you guys want to phrase it usually. So the data scientists, they're the ones that actually create a lot of models. I think that the sexy position nowadays that everyone wants to be. And then the machine learning engineer actually do something similar, is that they understand the models, they take that and develop that model into a working software model so everyone can use it, right? So, but to all of that process, those are the 2 sexist positions right now. But actually, a lot of the work happens before they even start. Like, for example, if we don't have data analyst or database admin on the team, then that responsibility falls into the data engineers and data scientists. So now what that means, who's cleaning the data? Data scientists is cleaning the data. So if with a small organization, actually the data scientists spend 80% just cleaning and labeling data, as opposed to writing and creating algorithms. Right? So with machine learning engineer as well, if there's not a lot of backend support, they do a lot of that. They help. A lot of times they're not very well versed in those specific data points. What happened then is that they just do a lot of iterations and a lot of work on unstructured data, which is not that great either. So what happened then is that usually you have at least 2 positions to help machine learning engineer or data engineers and the data scientists. So one is data analysts. So basically they're the one trying to clean all the data, label all the data, so when it's used, so that when you actually run the algorithm on it, it's not garbage in, garbage out, right? So of course, all data has to be stored somewhere. So nowadays, it's a lot better because with Amazon, Microsoft Cloud, you have a lot of tools now, right? So you know how to create an off-the-shelf server. You can actually use their tools. That helps managing where the data flow is. And of course, multiple data comes from different endpoints. And sometimes the model requires you to use data at different products and merge it together. So how the database is structured, it will influence your computation costs, as well as it'll help you with your model training time. So that is very important, because the faster you're able to train your model, the more iteration you can go forward. So that's a typical team environment. Now, here's our different roles I'll go into. Any questions, let me know. So the first is basically data engineer or machine learning engineer, like the sexiness. So for that person, usually in the startup, that's usually the first role they hire, because they're the one that usually can do a lot of things. One, usually they come from a computer science background, so that means they don't have a code. They usually have some experience managing databases. And third, they also are really interested in AI, because that means they have dabble and learn about different kinds of algorithms. So in a way, they can fit in really well in the beginning, almost anything they can do. But of course, you know that no matter how well they are, they're not the best at doing the modeling, right? They know some, but they're not the best. So that's a typical profile of machine learning engineer or data engineer. Any questions so far? And then next is the sexy one, is a data scientist, right? So usually for data scientists, most of them have a PhD of some sort, or have very well versed in the different algorithms. So usually, even when I was interviewing different data scientists, I need to make sure they understand some of the basics, right? The recall, precision, all of this, the simple mathematics first. If they can't even understand that, there's no point. And with data scientists, even though they say they're doing a lot of cool different things, but if they're not able to explain their concepts and algorithms to the people around them, they're pretty much useless, right? So data scientists, so even though they have a lot of skills with machine learning, etc., they also need to be able to communicate their models to the team, so the people can actually develop that model for them. Otherwise, if they can't communicate that, then the model never gets built correctly in terms of coding it up, etc. So the other one is more data analyst. So usually that one is more focusing on cleaning up data, making sure all data is ready to go. So when you first get data, so right now it's very easy. People always talk about data, but it's really easy to get data, but it's really hard to get good data. So any data you get is going to be in garbage usually, unless you put some constraints and clean up so you can feed into the model and feed into the database, etc. So data analysts, a lot of time they have some skills. They're very technical, but they don't have to be. But they're the one that actually the first barrier to make sure that data coming in are good. So to think about it, also kind of flow into database management, etc. So that's one thing to keep in mind. And then another one is data architect. So it's one thing to clean the data. Another thing is how do you actually architect the data type, what they call feature engineering, right? So basically, sometimes data comes in, you got to slice it up into different chunks. And how do you package them and put them into different, say, databases, or put them into, feed that into machine learning algorithms. So making that data process very optimized. So this area is, so this area basically, like I said, is, they really understand database architecture, how data is structured. So if people who love data and how we manipulate them, this is perfect. But for those who hates looking at data, just want to do the cool stuff, this might be kind of boring to them. So this one is more of database admin. So after everything is created, someone has to maintain it, right? So in this position, someone who's basically making sure everything's great, teams can be queried, there's no downtime. So sometimes this one is in combination with DevOps engineer. They kind of share that responsibility as well, because they want to make sure that everything's ready to go. Also with them, sometimes they also go into security as well. So because the database is locked, sometimes they have contained sensitive information from the customers or from your even employees itself, right? So I make sure that how do they make sure that no hackers, nothing can get into it. So the combination of make sure the data's good, as well as preventing outside intrusions that you don't want your data to be leaked out. So another one is the business analyst. So this one almost flows, usually only exists. It's a segue between the data team, the technical team, and the business team. So think of them almost like a semi-product manager, where basically they are trying to bridge the communication. They try to get all the requirements, what's on the technical side, what's being done, etc., and connect that to the business objectives. So they're almost like the leeway in the data team between them, if there's no centralized product manager in place to help them. So that's also one of them. So they are more of a project manager, semi-product manager type of mindset. So also, lastly, it's with the statistician. So they are also so they are the pre-data scientists, if that makes sense. In the past, so actually, I'm not sure you guys know, but most of the machine learning, AI, deep neural networks, a lot of it is built on statistics. So statistics are basically what drives everything. So in the past, they're the one who drives everything. So for example, your life insurance, when you're going to die, predict when you, predict a lot of different, like game of chance, gambling industry, they're the one who's there. But with the advent of data scientists, what happens is that they're able to look at problems in a more holistic way, where here these people are more centralized into more pure mathematical modeling. And sometimes they don't have the expertise to communicate that into a business objective. So that's what separates them more of a statistician versus more of a data scientist. But because of the growth in data scientists, what happens is a lot of those typical roles data statisticians are now becoming outdated. When I say outdated, I mean the title becoming outdated. So even then, you can see actually that type of role actually being worked on and call themselves data scientists, because they are a sub-branch of a data scientist. So I think, this is actually the last one. So my presentation is pretty short because I want to get more questions and answers than me just talking the entire time. So this is the one where you actually manage the entire data team. So they actually come in different forms. This is the generic title where they say data analytics manager, so all data. But actually there's also an AI manager, AI depending on the team. So how the company as well. So depending on how you structure it, they are all very different. So with data, so just say the manager of the entire data team or the analytics team. They are basically in charge of making sure that everyone does their job well, making sure the right metrics being used, the right project being scoped. So a lot of times they come with an analytics background themselves, because if they cannot have that background, imagine you're working for that person don't know what he's talking about, and tells you, oh, this will take you a week of time. Like, no, I ran this model already, it'll take at least 2 weeks, right? So a lot of times they have to have some sort of knowledge, whether that's in the database side or on the modeling side. But most like for managers, because of how hot data scientists are, a lot of them actually don't have that, because simply data scientists now are considered prize unicorns. So that means a lot of people want to do data scientists, become data scientists, even though this is another avenue they can go into. So right now, I would say one of the issues with this role is that a lot of them don't have as much technical background when they're managing the staffs. So sometimes there's miscommunication. Sometimes they don't know how to give directions on what to target on. So I believe that is pretty much my entire presentation. I just want to see, are there any questions about anything at all? I'm open to taking questions whatsoever. Hi.
What kind of personal projects have you done?
Personal projects?
Yeah.
Personal, not work projects, right?
Yeah, no.
So right now my work's taking a lot of my time. I haven't done any personal projects. So I was talking to Ben, I was at a hackathon last weekend, where we were trying to actually create a mood sensing assistant using Alexa. So what happened, we're trying to do, so at that point we got the resource API, we got an API to all this proprietary data from the various entertainment companies, the songs, the categorization, the data that categorize every single song. For example, is a song happy, sad, etc. And it turns out each song are categorized by up to 20 different categories of mood. and also give a different rating. So what happened then is what I did with the team is trying to figure out, based on the sense of your mood, what inputs to put into. So initially we had the temperature of the room. So if it's cold, you're probably going to be less happy. If it's warm, you'd be more happy. The weather, other sensory information, and most importantly, user feedback. So because now I'm also working with design, so how you develop AI is very important. So if you have good AI that automates everything, but people don't like it, it's pointless too, right? So also get user feedback so that when you have a prediction, but at the same time, on the back end, but at the same time, still ask the user how you're feeling, and the user respond. You take those two and merge it together and play a song in the beta database. So in this case, for a hackathon, we didn't actually make a really fancy database. We just say, here are parameters to check the rating of the mood and the mood category, genre, and look at typical what kind of song it is, whether that's in a popular song or unpopular, and then just play that for that user. So that's the most recent personal project I worked on, but I haven't been working on as many personal projects. On top of that, I'll also advise different startups. So sometimes I'll help a startup go from 0 to 1, basically telling them what they go wrong. So one project I worked on is that they were up and running for 3 months, but they were not getting any revenue. And the issue wasn't because of their algorithm or wasn't because of the data, it was because of their psychology. So they try to optimize the algorithm to perform very efficiently, but the psychology is wrong. So in the first half of psychology, they come across like a very warm and fuzzy feeling, saying, hey, come, we'll do anything for you. But once they get to the latter page where the funnel will try to get people to buy, they create a fear tactic. They say, if you do this, you're gonna miss out, right? Kind of what they call FOMO. So because those two psychologies are very different, even though their entire algorithm is completely optimized for the flow, processing time is perfect, everything's great, but because the psychology is opposite of each other, people weren't buying. So I have to help them fix that, the funnel, so even though it's sometimes at the expense of their technology debt.
How do models get more complex as like you grow them bigger? Do you have like more parts that are different neural nets, or do your neural nets kind of expand in size?
What's your name, by the way?
Andrew?
Andrew? So can you repeat your question one more time?
So like as you get a more complex project, like I'm sure Silence has some intense like models.
My friend works with Silence actually. Go on.
Yeah, like how do they grow in complexity? Because all I've ever seen is like neural nets that, you know, take pictures and turn them into something. What does like a more complex model look like?
So take that Silence model as an example, right? So if you have so neural networks basically all it does is, you don't know how it does, you basically preset actually different parameters, how deep you want to go into, and that gives you a certain confidence interval. And the deeper you get, the more cost, right? So more computation cost. So a lot of time when things are complicated, not because they want to make it complicated, it's because they have to make it complicated so that they can hit their accuracy rate. So it's not that things expand, it's more like in the beginning, they already kind of determine what's our accuracy rating. Okay, here say for example, we need to be 99% accurate. So they first do like say machine learning or small 2-layer neural networks, see how it performs. Now, if they can't get to where they want to go, they need to either expand the neural, that's how they start expanding the neural network. So in the case for Silence, if they're having trouble predicting with accuracy the type of spam or type of specific virus or hacking that's being done, then they need to increase the neural network, as an example. So I wouldn't say that expands naturally. I'm sure there's more inputs coming in, sure there's a lot more things to consider, but when they run their model, a lot of times that they have an idea how to structure that already. If you run a typical problem and it starts to expand exponentially, that means you didn't scope your model well. Usually that's an issue actually.
Okay.
Cool. What's your name?
Madhu.
Madhu.
Do you have any specific recommendations for either academic enrichment or opportunities that students can take part in during the summer?
So I would actually advise you guys to do more internships than taking classes, actually. Unless the classes are can help you understand say, artificial intelligence better or different skill set, because how you do, what you learn in classroom is very different from what you learn at work. So even now when we hire different people, we actually care more about what they have done in their internships than say the class they listed. I know in the resume section you guys list the class you took, etc., to market yourself well. Usually, even as a hiring manager, I actually don't care that much. I care more about your actions. What have you done? So actually, what's more important is what kind of personal project you've been worked on, and link to your portfolio we have done. So take classes there that helps you make that more prominent. I would say that's probably a better avenue. Cool.
Are there any like projects in particular, like, or any, not beyond just projects, like example projects or something, right, that you recommend that people just start off at, like, I don't know, image classification for some example, or something?
Actually, if you think you're good enough, you can start trying the Kaggle competitions, because that will really stretch you. So a couple of my coworkers, they're doing pretty well, but once they went to the Kaggle competition, they were humbled. So perhaps if you think you're at a certain level, that's you should start doing that. But if you're more in the beginning level, then I would say pick a focus that you want to go in, whether it's image processing or certain things, and just go from there. And one thing, since most of you are an EEC student as opposed to math, physics, statistics, is one of the dangers. One of my ex-coworker, he's a computer scientist, and he loved neural networks because he didn't have to do any feature engineering. He said, "Oh, just dump data in. The neural network will fix everything for me." And usually that's really the wrong approach, because you have to understand how the model is supposed to work. What happened then is he said he got a really good accuracy rating, right, for his data set. And then we gave it a brand new data set to run his model on. Usually always fails, because he just optimized that model. I think there was so that's, I think it was by, it's not good. So he always ended up overfitting the model for whatever reason. He tried to make it non-biased and not underfit, not overfit for his model and get the right accuracy rating. But when we gave him a new data set, it usually always fails. So just one thing to understand, really understand the principles behind how you structure the model and what the model does as a first step. And once you get to well enough, I would encourage, if you have the chops, time to do a Kaggle competition or a contest.
So do you think?
What's your name again?
Silver.
Silver.
Yeah. So do you think AI positions care more about degree, or do you think there is a trend that like the AI positions are like more generalized to like people without a master or PhD, because there are so many APIs out there?
Well, it depends. Like all these positions are listed, right? So their positions are geared towards PhDs. The other position that's not geared towards PhDs, right? So I would say, so for if you're depend on what you want to do. So sir, what do you want to do?
Let's say data scientist.
So as a data scientist, you probably have to have a PhD. Sorry, because because what happened, the data model are the modeling is so complex. Usually, and not only that, data scientists, they go to conferences every single month, because anything they learned within the past, say, school, etc., is outdated. In a month or two, it's outdated again. So what happened then, you need to quickly pick up new techniques, new algorithms, new how you pose problems at those conferences, right? If you don't have that PhD background or that advanced background, how can you absorb that quickly? Say if you never got exposed to say common filter or something like that, and you're suddenly going into a contest even more advanced than that, or utilize that part of it, and then say it take you like a month to learn it. By the time you finish learning that thing, it becomes outdated again. So you're never able to accomplish anything. So for data scientists, not that the degree matter, it's more about what you get from that matters. So usually, and because of that is important for data scientists, we usually look for people with at least a master's at a minimum to a PhD, because the stuff you learn in the undergrad level usually don't cover that much depth. Amy, right?
Yeah.
Okay.
What position would you say has like the best work-life balance between like
In which kind of position?
as in like a data scientist, machine learning engineer, and like everything that we kind of talked about?
It's less with the position and more with the company, actually. So I know companies where, yeah, it's actually less with the positions and more in the company. So of course, depending on the phase of the project, one is more stressful than the other. So for example, if you're cranking out new models, data scientist is more stressful in that period. But once the model is cranked out, now someone has to execute them. The machine learning engineer or data engineer have to execute them. That becomes more stressful. But in reality, in terms of work-life balance, it's more, I would say, the company. Look at the culture. Some company, if they see you working at 7, they tell you to go home. And some company expect you to work until like you finish what you're doing. They don't care how long, right? So it really depends. And I would say really focus on what you like to do as opposed to looking at what's work-life balance. Because if you like the area that you're working on, even though you work an extra 2 hours, 3 hours, 4 hours, you won't feel that tired because you kind of feel like you love what you're doing. So I would take that angle as opposed to say which one gives me the RI, the optimization, from that approach. Cool.
What do you think a person coming into AI should look for in internships?
What do you mean by that? Person coming to AI? Do you mean a
Like-
person who's going to AI?
I wouldn't say like, as a complete master or like, as like a graduate student, rather like, like one of us engineers who are, working previously in CS and are going into AI, learning the skills or have learned the skills. What do you think would be good, like?
When you say learn a skill, what kind of skill do you mean? Because AI is too broad, it's too
Okay,
generic
fine,
too.
fair enough.
So I want to understand.
Like
So I can
machine
understand
learning,
Okay.
like let's say you built, your own classifiers or something.
Okay.
They've delved into neural networks. Or what do you think they should look for in internships?
In that case, they should look for, make sure that the team has at least one data scientist, so they can validate your learnings, right? So, and make sure make sure during the scope of the project, you get constant, maybe not 100%, but at least 20, 30, 40% of your time exposed working alongside with a data scientist. Because then they can tell you, pinpoint a lot of areas you think you know based on your reading. They can say, no, you don't do it this way. They will, a lot of things that took them years to learn, they would tell you, as opposed to you go banging on the keyboard, cranking on a model and say, wait, why it's not working? They will tell you why that's not working. That's really helpful.
So what does the corporate ladder look like if you want to get into these positions? So I'm assuming like the data and analytics manager is at the top since he's managing all the data scientists and analysts. So what does it look like from starting from an intern, starting from an intern to masters or
No,
PhD?
so all these positions are not related. I mean, they're related, but not really. So so basically, they are all broad categories. So what that means is that you can start out as a junior data analyst to become data analyst, senior data analyst. Same thing with data scientists. You can become a data scientist, senior data scientist, principal data scientist, right? So they're all individually career tracks. Even for managers too, they can be manager, senior manager, director, etc. So depending on organization, it can go up that way. But I think in a lot of tech companies now, titles don't mean much. It's more about what you do. And I know people who have lower titles gets paid more than someone with higher title in a different company. So in terms of title, depending on the company, it's different. But I would say each of those roles have their own singular tracks, as opposed to you can move around for sure, but it's not like, oh, gotta be a data analyst first, then they can be a machine learning engineer. No, it's not that. It's just they all have their own unique role in that organization.
So, following up the resume question, so if you want to hire a data engineering intern or data analyst intern, what specifically are you looking for in the area, in terms of skill sets and experience?
Say that one more time. Which two positions?
Data engineer or intern or data analyst.
So it's someone who loves data for data analyst. If you tell me, I would test you. I will not test you with questions. I will test you in. I'll probably catch you. So the way I do things, I interview people is like, a lot of people prep for interviews. So obviously, if it's prepped, so a lot of times I have to throw curveballs. So sometimes you will give me a story, and then I'll say okay, and I'll pick a different story that you imagine. So it's to really understand if you like data or not. So for data analyst, make sure you love data. If you like data, there's no point going data analyst. And for data engineer, of course, it's data engineer, right? So you gotta love data, and you love to do programming too, right? A lot of it is more programming than actually writing algorithms. So if you don't like any of those and say like, oh, I just want to do process, something like that, that's one. Second is the technical skills. So if you, depending on this, we expect you to understand how to manipulate data, how to structure data. That usually is different depending on the seniority of the position, I would say. Madhu?
Do you know any specific companies, like big or small, that give opportunities to beginners in machine learning or data science?
Big or small? For intro level positions, probably bigger companies will, I would say. I don't know exactly which one, but bigger companies will. For smaller companies, we want you to execute right away. So what that means is that you gotta, once you come in, you're executing. No barely any training whatsoever. So I would say probably bigger organizations, and also organizations that have a big data team or the AI team. Some are big, like I think for example, maybe like consumer goods team. So you know it's a big company, but their technical team probably is a bit smaller, so it might not be the best fit. So I will go for big companies, bigger companies, and within that division have a very big like AI team or machine learning team.
So when you're looking at someone's resume, what are you expecting most from his independent projects?
Depends on the role.
Yeah,
You gotta be more specific.
So I mean, like, are you so for whatever? So for all the roles, like, are you are you expecting like more about the technology he was using, or more like the practical meaning of this project?
I would say more on, so depending on the role. If it's a technical role, I would say, is the project interesting? On one. How difficult is the project? And looking at the documentation, thought process. Those three things. And then I'll, as a barometer for technical projects. For non-technical projects, I have a different set of measures. Sure.
How do you think AI or more specifically machine learning can be put in blockchain?
Put in what production?
Production, yeah.
Production?
Blockchain.
Blockchain? I don't know. Because blockchain, as far as I know, is that everything is decentralized, everything is captured, etc. The only thing I can think of right now is probably with smart contracts. So expedite that process very quickly. And then because eventually the blockchain record will be huge, right? Looking for a query or looking for a specific item, and then correlate that with the differentiated system, maybe. But in terms of beyond that, I don't know well enough both systems to say. I don't know blockchain well enough to say what can be used for. But the only thing I think of is probably just smart contracts and optimize that at the moment. One more question.
If you're just like a general career scientist and you're like, you have like no direction on what career path you want to take, do you have any advice on like trying to find that direction?
Yeah, just take as many classes as you can, and then say, do I like this? No. Okay. Do I like this? No. Who knows? Maybe you don't like data computer science at all. You never know. I'm serious. I'm not doing engineering anymore. I'm doing more design now. So the psychology of things, I like that a lot. So I ventured out of computer science. I mean, when I first graduated, I was doing software for spacecraft. Right? It was cool. It was fun. And then after a while, decided to switch. So who knows? Just take. So don't be pressured to figure out what you want. If you don't know what you want, just try a lot of different things. Then you can start checking boxes off. So it could be after 4 years, you realize, man, I'm glad I got this degree, but man, I don't ever want to touch a line code ever again. That happened to my friend actually, and she changed and she went to consulting instead. So, I mean, it's scary, but at the same time, it's better to do it now than to wait until you're 40, 50, 60, and then be like, man, I hate this stuff. I hate this stuff, but I have to do this stuff, right? That's worse. Yeah. By then you'll be making so much money that you can't let go. Well, no matter how much money you make, when you first get out of college, it's nothing compared to what you make 10 years from now, 20 years from now. So.
Alright. Okay. So can I get everyone a round of applause for